In this video, I'll be covering question 6, part C from the 2023 AP Calculus AB free response, no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see my other solutions, please check out those other videos. Okay, so diving into C. C this time wants us to find the coordinates of a point on the curve at which the line tangent to the curve is vertical. We saw in B that really horizontal tangent lines happen when you've got the top of a fraction set equal to 0. When we're talking vertical tangents, that's when the bottom of your derivative is going to be equal to 0. So we have this equation over here, 2y squared, 2y over y squared minus 2x. Think about vertical as vertical asymptotes. Remember, vertical asymptotes occur when the bottom of your fraction equals 0. And then just extrapolate that into this idea. We're looking for a vertical tangent, so this time we want to know when does the bottom of this derivative equal 0. So we'll set that equal to 0. Notice right away that you've got two variables in this problem. You're never going to solve this equation by itself because when you've got two variables, you always need two equations to do it. So to start off here, we're not going to go for a final solution. What we want to do though is solve this equation for one variable so that we can plug it into another equation, say this one up top here, and solve that then to get what we're looking for at least one of our variables. Well, the easiest way for me to do this would just be to solve it for x. If I solved for y squared, I'd end up with some square roots and some other stuff going on that I don't want to worry about. So I'm just going to get x by itself. So I'll add 2x to the other side to make that positive. And then once I've done that, I'm going to go ahead and divide by 2, and we end up with y squared over 2 equals x. Now that we've got that, now we go to our other equation. Remember, whenever you've got two variables, you need two equations to get a solution. So we're going to go back to that original equation. 6xy equals 2 plus y cubed. And I now have a value for x. So I can replace x here with this equation here, and now this equation up top is only going to have y's in it, so I can solve that. So this would now be 6, and instead of x, I'm going to plug in y squared over 2, and then we've got y times y equals 2 plus y to the third. Now we want to solve this equation to get y by itself, so we'll just start cleaning it up. I get 6, this 6 on top and this 2 on bottom, they're going to cancel. That'll leave me with a 3 right here. And then y squared times y is going to get me y cubed. So we end up with 3y cubed equals 2 plus y to the third. We'll go ahead and collect all those y cubes together on one side. We're just solving for y right now. Straight up algebra. 3y cubed minus 1y cubed is going to get us 2y cubed equals 2. And then we'll go ahead and divide by 2, divide by 2. We get y cubed equals 1. Quick little cube root action. Cube root both sides. And out of there we'll end up with y equals 1. So we have one portion of what our point could be. Remember that when they're talking about the coordinates, coordinates mean we're talking about an x and a y. So I know what the y value is, and if you watched my video for B, you know where we're headed now. We're going to go ahead and plug y into this equation, this starting equation, and see if there's an x value that comes out of there. If you watched B, you know that we plugged in our value and we did not get an answer out. Let's see if that changes on this one. So I'll take my y value of 1 and I'm just going to pop it into this equation everywhere I see a y. So we'll get 6x times 1 equals 2 plus 1 to the third. This is looking better than part B because on this side we've got 6x, 1 times anything is just itself, equals 2 plus 1 to the third, 1 to the any power is 1, so this will be 3. And then we'll go ahead and divide that 6 over, and we'll get x equals 3 over 6, which they would want you to simplify down to being 1/2. So here we actually do have an answer. We've got a y value of 1 and an x value of 1/2. So you would want to sort of draw this conclusion at the end here for them. You would say at x value of 1/2, y value of 1. So at that point there, the function has a vertical tangent. and you'd be done. And so we would have gotten 1 point on here from setting that just the bottom equal to 0. You'd have gotten 1 point out of there for getting that y value correct. And then you would have gotten your third and final point on this by getting that x value and combining it with your final conclusion. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.